All right, welcome back, everybody. We are up to lessons 8 and 9 of Unit 1. This particular video will cover both lessons 8 and 9. And what both of these lessons are about is something called the closed form, also known as the explicit form of a sequence. We've already talked about the recursive form or the recursive definition of a sequence. What the closed form or explicit form is, it's just another way of expressing the values mathematically of a sequence. So it's a formula that directly computes a specific term of a sequence. It is not necessary to know the previous term. And that is the key difference between closed and recursive. With recursive, in order to find a specific term, you have to know each of the previous terms prior to that. So, for example, if I wanted to figure out the 100th term of a sequence, if I was doing the recursive, I would need to know the 99th term in order to find the 100th term. But in order to find the 99th term, I would need to know the 98th term. And in order to find that, I would need to know the 97th term, so on and so forth. With this closed or explicit form, I can calculate the 100th term directly without having to find the 99 terms prior to that. So that's an advantage of the closed versus the recursive. So we have here the two formulas for the two special types of sequences for closed. We have the one here for geometric sequence. So f of 0, remember, is your starting term of the sequence. And r is your common ratio. So that's the number that you're multiplying by every time. And then for an arithmetic sequence, again, we have f of 0. And then we have d for common difference. That's the number that you're adding or subtracting each time. So with that in mind, let's go ahead and take a look at the examples here. So for the following sequences, determine whether it is geometric, arithmetic, or neither, and then write the closed form. So what I'm going to do is what I normally do is I'm going to go through each of these sequences, and we're first going to determine whether it's geometric, arithmetic, or neither, and then we'll go back and do the problems again and actually write the closed form. So number one pretty clearly looks like a geometric sequence. Okay, why is it a geometric sequence? Because we're multiplying by 3 each time. 5 times 3 is 15. 15 times 3 is 45. Okay. Number 2 looks like we have an arithmetic sequence. And our pattern looks like to go from 1 to -5 would be going down by 6. And then -5 minus 6 is -11. So my pattern is to subtract 6 each time. So this is definitely an arithmetic sequence. Number 3 is also going to be an arithmetic sequence. So that will also be an arithmetic sequence, because in this one we're adding 3 each time. 4 plus 3 is 7. 7 plus 3 is 10. And the last one, number 4, that's going to be a geometric sequence. Okay, because in this one we're dividing by 4. 12 divided by 4 is 3. 3 divided by 4 is 0.75, so our common ratio is going to be 1/4. Okay, dividing by 4 is the same as multiplying by 1/4. So we went through and did this part right here. Now we're going to actually go through and write the closed form for each of these sequences. So let's take a look. Let's actually go ahead and do the geometric ones first. So let's take a look at number 1. And what I'm going to do first, what I want to do first is go back and take a quick look at the lesson notes. And what we're going to do is we're going to rewrite the formula for geometric sequence. So f of n equals f of 0 times r to the power of n. So f of n equals f of 0 times r to the power of n. That is our formula for a geometric sequence. So f of 0, remember, is the starting term. So the starting term for number 1 is 5. So that's going to be a 5 times r is our common ratio. And we already said our common ratio in this case was 3 because we're multiplying by 3 and then to the power of n. So this literally right here is the closed or explicit form of sequence number 1, 5 times 3 to the power of n. So if I wanted to figure out, say, term 100 of this sequence, I could plug in 100 for n, 5 times 3 to the power of 100. If I wanted to figure out the 10th term, term 10 of this sequence, I could plug in n equals 10, 5 times 3 to the power of 10, so on and so forth. So again, this right here that I just circled is the closed form of number 1. I'm going to jump down and do number 4 since that's the other geometric one. So I'm going to, again, rewrite the formula. F of n equals f of 0 times r to the power of n. So f of 0, starting term, what's my starting term here? 12. And then r is your common ratio. So we've already said our common ratio is 1/4. Dividing by 4 is the same as multiplying by 1/4. So r, we're going to plug in 1/4 for r to the power of n. So my closed form for number 4 is going to be 12 times 1/4 to the power of n. So that's the answer to number 4. Now let's go and do the 2 arithmetic ones. So let's go back to our lesson notes and again take a look at the formula for an arithmetic sequence. So it's f of n equals f of 0 plus or minus d times n. So f of n equals f of 0 plus or minus d times n. So once again, even though it's an arithmetic, even though it's a different formula, f of 0 is still my starting term. So my starting term in this case is 1. Okay. Now, in this case, our pattern was to subtract 6, which means we're going to use the minus this time. So it's plus or minus. In this case, we're going to use minus because my pattern was to subtract 6. And in this case, what are we minusing? We're minusing 6. So 1 minus 6 times n. 1 minus 6n. That is my closed form of sequence 2. Once again, if I wanted to figure out term 100, I could calculate 1 minus 6 times 100. Or 1 minus 6 times 10 if I wanted term 10. So it's the same idea as the geometric sequence, just a different formula. Okay? All right, and let's finish this off and do number 3. So f of n equals f of 0 plus or minus d times n. So again, my starting term in this case is going to be 4. So f of 0 is 4. We're going to use plus this time because my pattern was to add. And in this case, we were adding 3. So my closed form is going to be 4 plus 3n. 4 plus 3 times n. And that is it for lessons 8 and 9 on closed form.